Greetings, everyone. Today we're going to explore the general form of hyperbolas and parabolas. We do have a foldable for this, so you'll want to make sure you have that ready. And if you are looking for the ellipses and circles in general form, please see my other video. Alrighty, a lot of the information in this video is going to be a repeat of the first video, so you shouldn't have to write any of it down. First of all, remembering that the general form of a conic can be written in this sense, having an x squared, a y squared, some xy values, constants, and all equal to 0. Let's review and refresh our memories on hyperbolas. Remember that in a hyperbola, we have a subtraction sign. That's the primary way it is different from an ellipse. We are equal to 1, so that matters as well, because only ellipses and hyperbolas are like that. And if we were to FOIL this out, multiply denominators out, this would be what standard form of a hyperbola would look like. A parabola is more unique and easier to identify because it only has one value squared. And so if we were to FOIL this out, distribute this, we would have a general form that looked like this. And so easy to identify to see that there's only one squared value. And so again, how do we know what type of conic it is without doing any work? If we pay attention to what's being squared, if two values are being squared, it's a circle, ellipse, or hyperbola. If one value is squared, it's a parabola. Then we're going to look at the coefficients in front of the squared terms. If the coefficients are the same, it's a circle. If the coefficients are different, it's an ellipse or a hyperbola. Signs. If the coefficients are different and it's addition, then it's an ellipse. If the coefficients are different with two values squared and it's a subtraction sign, then you know it's a hyperbola. So let's look at some examples here. Here I see two values squared, so can't be a parabola. I see that the coefficients are different, so that means ellipse or hyperbola. And I see we have a subtraction sign. They're different signs. Therefore, it's a hyperbola. In this example, I see that only one value is squared. Nothing else matters. It's automatically a parabola. Now, what if we want to graph the equation? What we've been spending time on is transforming that general form into something that we can identify and graph. Now, you should have these steps written down. This should be a review. As before, the exact same steps from the previous video. We want to group our x's and y's, and we want to send the constant numbers to the other side of the equal sign. We want to make sure that the coefficients of the x and y squareds is 1. We then want to complete the square by taking the x and the y value, divide by 2, square it. You want to add those numbers to both sides of the equations. Remember that if you divided out a factor in step 2, you have to consider that when adding it to the right side. This will create a perfect, nice quadratic trinomial that we can factor and write nice and neatly. Now, I know I zoomed through those steps a little bit quicker. If you need more time on those, of course, see that previous video. All right, step 1, let's identify the type of conic. I see that I have one value squared, so that means it's automatically a parabola. Let's go through our steps. Step 1, we want to organize, which means, so here's what's unique about a parabola. We're grouping all the x's together. See that? We're grouping the y's and the constants to the right side. So I minus 14 over, I added 2y over. So remember, parabolas have all x's on one side, all y's on the other side. Step 2, let's start completing the square. Or first of all, step 2 is divide out a factor if there is one, and there isn't. So I'm actually skipping step 2. Step 3 is let's complete the square. Take that b term, divide it by 2, square it. That gets me to 16. So I want to take that 16 and I want to add it to both sides of the equation. Because what you do to one, you got to do to the other. Which would make it look like this. What we've done is we've created this nice quadratic trinomial that factors perfectly. It factors to an x minus 4, x minus 4, which means we're going to write it as x minus 4 squared. And then we just have these constants off to the right that we're going to combine. Now, as you know from the general shape of a parabola, this is unique to parabolas, we have a coefficient outside of the parentheses. So if I look here, this doesn't look like a normal parabola. So we actually have to divide out a common factor of 2, a GCF, if you will. Now that looks like the form of a parabola. Now I can say that my vertex is at 4, -1. I can say that my p-value is 1/2. Now I can actually call direction and graph the function. All right, let's take a look at this next example, 33. First, we want to identify what kind of conic it is. Things I notice. I notice that 2 values are squared, so it can't be a parabola. I notice that the coefficients are different, the leading coefficients, so it can't be a circle. I notice that the signs are different. There's a subtraction sign there, so it has to be a hyperbola. Let's go through our steps. Step 1, let's organize the x's, the y's, and kick the constant to the other side. Step 2, we do have leading coefficients for our x and for our y's, so we need to divide those common factors out. So technically there's a -1 there, right? So I'm going to divide out a -1 from both x's, divide out a 4 from both y's. Let's begin the completing the square process. We're going to take our b values, we're going to divide them both by 2 and square them. Now that I have those nice clean numbers, I'm going to add the x number to my x's, add the y number to my y's. Now be careful when you add it to the right side. When you add it to the right side, don't forget you have those factors out front to consider. So a -1 times a 1, let me color code this, help organize this information. A -1 times a 1 leads me to this on the right side. Okay, a 4 and the 9 leads me to this on the right side. That's going to be tough to remember. You can also see where I added that to each quadratic trinomial. What we created in that quadratic trinomial is something that perfectly factors x plus 1, x plus 1, so we write it as squared, x minus 3, so we write it as squared. Now if this is a hyperbola, it is supposed to be equal to 1. So I have to divide every piece by that 16 on the right, which is going to simplify it down to this. Now, it doesn't quite look like a hyperbola because of this negative remaining, right? We've never ever had a negative in the denominator. And so the way to deal with this is let's turn it into a subtracting problem. Let's actually flip the fractions around. Because remember, a hyperbola has a subtraction symbol. Because subtraction order matters, we actually want that y to be first, because that's going to help me graph it more accurately. So if you have a negative, not a big deal. Flip it around so it looks like a subtraction problem. Alrighty, let's take a look at example 35. The first thing we want to do is identify the type of conic. And so I notice there's two values squared, which means it's not a parabola. I see that the coefficients are different, therefore it's not a circle. And I see we have a subtraction sign, which means it has to be a hyperbola. First step, we want to identify or organize, the x's and the y's. Now, I don't have an x term, all right? So we're going to have a filler of x squared. I have leading coefficients, so I need to divide those out. Let's divide everything in the x's by 4. And let's divide everything by the y's by negative 25. We want to take that negative out, okay? Next step, let's complete the square. We want to take our b values, divide by 2, and square them. We're going to add the 0 to the x's, add the 9 to the y's. We're also going to add them to the right side, but we need to take into account our factors that we divided out. So let's take a look at how that plays out with those factors. So again, I had a 4. So when I add that 0 to the right side, I have to times it by 4. I had a negative 25 out front. So when I add that 9 to the right side, I need to multiply it by negative 25. The sign matters. Watch out for that, okay? What we did is we created this nice clean quadratic that we can factor. X squared plus 0x plus 0 is just going to be an x squared, okay? You could write it as x plus 0 squared if that's helpful. Please do that. The y squared plus 6y plus 9 factors to a y plus 3y plus 3. So we write it as squared. Next, we know that if this is a hyperbola, my function, or my conic needs to be equal to 1. So that means I need to divide every piece by negative 100 because it needs to be positive 1. So when I divide everything by a negative 100, now you might naturally just keep that negative on the bottom. That's fine. Doesn't matter either way if it's on the top or the bottom. But we've got our nice clean equals to 1, right? Now, as we know, we never have negatives like that in our conic, so we are just going to flip the fraction around so that it becomes a subtraction problem. If it's a subtraction problem, that tells me that this is a hyperbola. And again, maybe you have an x plus 0 in here. That's totally fine. But now I have all the details necessary to graph easily. Let's take a look at number 36. First step, let's identify the type of conic it is. I see that there's only one squared value. That makes it so much easier, right? It has to be a parabola. All right. Remember, parabolas are a little different. Because the y is squared, we're going to put all the y's together on the left, and we're going to move all the x's and the constants to the right. See how I did that? Next step, you want to see if there's a leading coefficient, which there isn't, so I don't have to worry about that step. So let's jump to step 3, completing the square. Let's take our b value of 6, and we're going to divide by 2 and square it. That creates a 9. Now I'm going to add 9 to the left side and to the right side. We completed the square and created a nice factorable quadratic trinomial on the left, and on the right side we can add those constants together. Y plus 3 and y plus 3 gets simplified to the quantity y plus 3 squared. Now it doesn't quite look like a parabola because normally we have a factor out front of a linear polynomial. And so I need to divide out a GCF of negative 12. Now this looks like a parabola. Now I could figure out my p-value. That would be negative 3. I know my vertex would be at 5, negative 3. I know that it would be a parabola opening up to the left. Right? Now we have all the details we need. It looks like the problems we have graphed. All right, that is our lesson on standard form of a hyperbola and a parabola. Make sure you check out Google Classroom or the previous video if you felt like I went too fast in this one. Let me know if you have any questions, seek out other resources if needed, and until next time, have a good one.